Okay, this is equations and units practice number 2. Right, follow the steps. Extract the data. Choose a formula. Convert and check the units. Substitute. Solve it. Round it. Add your own individual units. Follow that pattern every single time and you'll get all of them right. So, a current of 15 amps. Current 15 amps, this is me taking the data out, flows through a 5 ohm resistor. Resistance 5 ohms. Calculate the potential difference. Go to my formula sheet, look all the way through. Potential difference equals current times resistance. Potential difference measured in volts, current amps, resistance ohms. Now, numbers look all right. Substitute in. Potential difference, current is 15 amps. Don't need to put the A in. Multiplied by resistance is 5 equals 75 volts. There are 2 resistors in a series in a circuit. Resistor 1 has a resistance of 3 ohms and resistor 2 has a resistance of 2 ohms. Calculate the resistance in the circuit like this. Right, so let's just draw a circuit. I've got a picture in my head now what's going on. So there's 2 resistors. Resistor 1 has a resistance of 3 ohms and resistor 2 has a resistance of 2 ohms. There's my circuit. Okay. I'm just going to make it a little bit more interesting and I'm just going to add on another one, right, which is then parallel. We're going to have 3 ohms and we're going to have 2 ohms. Okay, and I'm going to add this in here. This is just a bit of extra, bit of fun. You know what I mean? Oh, God, that's terrible. I should get a line down there. Right, so the first one. Calculate the total resistance of the circuit. So we do the series one first. Series is where there's only one route for electricity to take, which is from there all the way around and back to there. The resistance, all you do is you do 2, add 3 equals 5 ohms. So that's the answer to the question that I've got up there. This next one is then a parallel circuit. The resistance of this is always lower than the smallest resistor. So the answer is less than 2 ohms, less than 2 ohms. A PlayStation 5 has a current, I don't care whether it's a PlayStation or whether it's an Xbox or whatever it is, current 0.6 amps and a potential difference of 230 volts running through it. Calculate the power. Okay, so equations, right, if it's in your head, that's fantastic. If you need to go and look at the sheet, but obviously, you know, it benefits you if you learn them. It is power equals potential difference times current. Now obviously you write them out in full. Watts, volts, amps. Substitute in. Potential difference 230 multiplied by the current 0.6 equals 138 watts. A set of GHDs. Okay, now if I knew what GHDs were, I'm sure it would help me a little bit, but obviously I don't. It's probably something to do with hair, because it's got a H in the middle of it. Right, current of 0.05 amps, a resistance of 20 ohms, calculate the power. Look for my formula, either in your head or from your formula sheet. Current, so I've got power equals current squared times resistance. Okay, current is in amps, resistance is in ohms, and power is in watts. So current squared, so we've got 0.05 squared multiplied by a resistance of 20. Okay, so I'm just going to do this in kind of like on my calculator, so I'm going to do 0.05 times 0.05 times 20, and it actually works out to be 0.05 watts. A toaster, I know what a toaster is. Power of 200 watts, switched on for time 75 seconds. How much energy transferred is there? And energy transferred is in joules. Look for my equation. I'm going to do a different colour now, I'm bored of red. I'm going to do power in watts equals energy transferred, which is in joules, because energy is always in joules, divided by time in seconds. Substitute in. Okay, 200 equals energy transferred, don't know it, divided by 75. Got to do something here now, got to think. If that's divide on that side, then what it does, it becomes times on the other, so I'm going to do 200 multiplied by 75, because if it's divide on that side, to make it go to the other side, you times it, you do the opposite, equals energy transferred. So energy transferred equals 15,000 joules. Okay, well, a little bit of algebra, I don't like that. A lamp with a potential difference of 230 volts, so potential difference equals 230 volts, has a charge flow of 30 coulombs. What is the energy transferred? Equation, energy transferred, that's in joules, equals charge flow in coulombs multiplied by potential difference in volts. Substitute in, charge flow 30 multiplied by 230 equals 6,900 joules. Okay, again, right, follow the steps that I said right at the very start. If you follow the steps, you're going to get them right. Okay, watch out for units, right? There was no units issues in that one at all. And there was one where you had to do a little manipulating around. Okay, but just be dead careful when you're doing all these different types of questions.